to design our reinforced concrete beam under the effect of shear. And we talked about stirrups. Stirrups is called transverse or shear reinforcement. Is rectangular shape with rectangular shape of steel at equal spacing. These elements or these reinforcement is responsible for supporting shear force. And we talked also about torsion. Torsion is another kind of internal forces which is supported by stirrups also. We will cover torsion next time. Our design philosophy is your factored internal forces from structure analysis must be smaller than or equal your design value. So if you are talking about shear, the factored ultimate shear from structure analysis, from shear force diagram, must be smaller than or equal the design shear strength. Shear strength of any reinforced concrete beam is supported by two terms. First one, part from concrete itself. The second part from steel, transverse or shear reinforcement. The first part from concrete equal to B web time depth time square root of FC prime. The second part from steel equal AV F yield D over S. S spacing between stirrups, it's equal spacing, and AV, what is the value of AV? Cross-section area for this leg plus cross-section area for the other leg. If your stirrup with two legs, you can get the area of one leg times 2. Maybe your stirrups with 4 legs, 1, 2, 3, 4. So the area of one leg times 4 equal AV, equal AV. The common diameter or common size of stirrups, number 3, stirrup number 3, with area of cross section 0.11 inch square, or number 4.2 inch square. To design your stirrups or to calculate the distance or the spacing between stirrups, first, what is the shear force diagram of your beam? But before drawing your shear force diagram, be sure you multiply your dead load by 1.2 and your live load 1.6. That means your shear force diagram, the maximum value in your shear force diagram can tell you what is the V ultimate from structure analysis. Second step, what is the design shear strength of concrete only? Phi Vn. Anybody remember what is the value of phi for shear?
0.75.
Yeah, for shear or torsion, your phi equal 0.75. It's one value. Anyway, third step, assume diameter of stirrups and how many legs. It's important. What is the diameter of your stirrups and how many legs to be able to calculate your AV. Now, what is the spacing between my stirrups? We have 3 different situations. First one, if V ultimate from structure analysis smaller than or equal shear strength of concrete divide 2, that means we don't need stirrups. Concrete is enough. You can avoid to put any stirrups in your beam. stirrups not required. So no stirrups are required, concrete is enough, but at the same time I will put the minimum number of stirrups. Second case, if your ultimate shear force in between have concrete design shear strength and shear strength of concrete, that means you are spacing one of them, one of this value or this value, which one is smaller? AV F yield divided by 50 P web, or S equal AV F yield divided by 0.75 B web square root of F C prime. If you are in this situation, this one is you have high level of shear force. So calculate Vs equal V ultimate divide phi minus Vc, and you can get your spacing from this equation using Vs that you calculated before. So first step to solve for shear, to draw your shear force diagram. Once you calculate your stirrup spacing, we need to check this spacing within cannot exceed the maximum spacing. Your maximum spacing depends also. First situation, if you are in this situation, that means your maximum spacing D divided 2 or S equal 24 inch. Second situation, we have two options. First one and second one, and you have to choose the smallest value of these expressions. Let's do the first example. The span length and the cross section of reinforced concrete beam are shown. The concrete and reinforcing steel properties are FC prime 2500, F yield 50,000. The beam supports a concentrated live load. I did something wrong. This one is 500 only, not 50,000. 500 pound. 500 pounds, not 50,000. Neglect self-weight of the beam. If the stirrups are number 3 bars with 2 legs, what is the spacing? What is the center to center spacing of your stirrups? S. We are looking for S. Okay. On one side, I have a beam. Perfect. Simply supported. Yes. Your span, total span, 10 feet. We have uniform distributed dead load. How much? 2 pound per foot. I'm sorry, 12 time 1.2 equal 14.4 pound per foot. And we have one concentrated load. How much? 500 pound live load, so time 1.6. You need to get your factored load. These are your surface load.
We gotta get our W, right, for live load?
I'm sorry?
Gotta get a W for live load?
No, we don't have W for live load. The only live load here is a concentrated load. 500 pounds. Nothing else. The dead load is a distributed load. That's fine. Maybe for any reason your live load supported by this beam only as a concentrated load. Anybody here can tell me what is the source for this concentrated load? What is the source? One body only is standing here with 500 pounds.
Heavy piece of very heavy person.
What is the source of a concentrated load like this? Okay, I know the distributed load. These discs are distributed load. That's fine.
Column?
But column? No. You have a beam and you have secondary beam. Secondary beam means this beam is supported by this beam at this location. So from structure analysis, if you solve this beam and you got your reaction here, this reaction is a concentrated load on the main girder at this location. You got it? So concentrated load on a beam means we have another beam in this direction. This beam has a reaction. This reaction is supported by this beam at this location. Okay? If you try to solve big structure with your hand, you will need tens of hours, because you have beam supported by another beam, and this beam supported with another column, and this column is supported with, it's more complicated. We are trying to solve very simple structure, but if we have a complicated structure, we will use software just after 1 week or 10 days. We will start to solve for complicated structure. Anyway, so we have only concentrated load as a live load. So 500 only time 1.6. We have uniform distributed load as a dead load. 12 pound per foot. So this dead load only time 1.2. So this value 500 times 1.6. 800? Yes. Bound. So what's your reaction?
400.
You have distributed load.
407.
This side only of your distributed load has equivalent force 14.4 times 5, 72 pound. And this side only has equivalent force 72 pound. And we have one concentrated load at mid-span 800. So this reaction will be 472 pound, and this reaction will be 472 pound. That's right? If you have issue with your shear force diagram, with your reaction, that's fine. Go ahead and use RISA, put your distributed load 14.4, put your live load 800, and solve for reaction and shear force diagram. No problem. Even in your exam also, you have your computer, you can open RISA and draw what you want. That's fine. I cannot prevent calculator, so I cannot prevent RISA. Both of them have the same idea. Anyway, if you try to draw your shear force diagram, go back to structure analysis, hey, go up 472. Then dot it, because it's a distributed load, until you hit 72, go down 72 until 400, keep going until your concentrated load. Wait a moment. From this point to this point, draw a line. You found 800 concentrated load coming down, so go down by 800. You are here at 400, so I will go down for 400. Keep going. I will keep going, but dotted, because it's a distributed load. Until you hit 72, go down by 72 until 472. Keep going until you hit your reaction will close to 0. From this point to this point, draw a line. Here is your shear force diagram. If you have issue with to draw shear force diagram with your hand, we are not in structural analysis course right now. So go ahead and draw your shear force diagram by RISA. That's fine. That means your V ultimate from shear force diagram equal what? 472 pound. First step, you need to analyze your structure. Structure analysis. Draw your shear force diagram to get your V ultimate. And also, if you go back, steps of design. First step, draw shear force diagram for the beam and calculate your V ultimate. What is the second step?
Feature.
Phi VC. Okay. Second step, Phi VC equal Phi 0.65 or 75 time. Anybody remember what is the value of VC? Yeah. B width time depth times square root of FC prime.
2 times.
FC equal to B web times D times square root of FC prime. So, what is the value of B web? 14. What is the value of depth? 18 inch. What is the value of your FC prime? 2,500. What is your value? Square root of 2,500 times 18 times 14 times 1.5. Your value 18,900. Count. Anyway, so what will be the next step? You can assume diameter of used stirrups. I think the problem said which number? 3 and 2 legs.